Next one, types of loads. Types of loads, my dear students. Okay. So, according to area of contact, there are three types of loads, my dear students. The first one is point load. Point load or concentrated load. Concentrated load. Concentrated load. The next one is distributed load. Distributed loads. Distributed loads. Under these loads, there are two types of loads here. One is uniformly distributed load. Another one is uniformly varying load, my dear students. So first of all, we will discuss about the point load or concentrated load, my dear students. So first of all, point load. Point load. What is a point load, my dear students? Point load or concentrated load. Now suppose if it is a beam, the load is acting over a small point, at a small point. This type of load, that is, this load is concentrated over a small point. That type of load is called as point load. That is either P or F. Okay. Now, so this type of load is called as a point load or concentrated load. Now coming to distributed load. Next one is distributed load. What is a distributed load? The load is distributed over entire length or part of the length. Such a type of load is called distributed load. Okay. So the load is distributed over entire length of the beam or part of length of the beam. So such a type of load is called as distributed load. Under this, uniformly distributed load. First one, uniformly distributed load. So here it is also represented with UDL. So see here, all of see, my dear student, now it is a beam. So this is represented by like this. This is uniformly distributed load. Sir, what is the meaning of uniformly distributed load? So for 1 meter distance, 1 Newton. Again, for another meter distance, 1 Newton. For another meter distance, another 1 meter distance, 1 Newton. Like that, the load is distributed over entire length or part of length also. So see like this also. So in this case, over entire length, the load is distributed. Now the load is distributed only part of the length. So it can be represented by like this, but this is also same. There is no change. Like this also, both are same. This is a representation of UDL like this. So it is the load is distributed over entire length or part of the length, but the distribution is uniform. For 1 meter, 1 Newton, 1 meter, 1 Newton, 1 meter, 1 Newton. Now it is represented by W Newton per meter. W Newton per meter, my dear students. W Newton per meter. Now I will continue here that one. Now here is, for example, length of the beam is L. Suppose here is UDL is acting like this. The total length of the beam is equals to L. Total length of the beam is equals to L. Now this load is W Newton per meter. UDL is represented with the W Newton per meter. So for every 1 meter, W is acting. For L meters, what is that? W into L. So the total intensity of the load is equals to W into L. Where it is acting, my dear student? This is in a form of a rectangle, yes or no? This is in a form of a rectangle. So at center of gravity point, this total load intensity is acting. So it is a rectangle, L by 2, H by 2. But we will consider horizontal line because load is acting length along the length only. So that we must consider the length dimension. Now here is, suppose here is, now I will write here. Now this is the length of the beam L. So L by 2 distance. For rectangle, where is center of gravity? For example, it is a rectangle. So L by 2 distance. This is L by 2 distance. From here to reach H by 2 distance. But load is acting in this direction, length direction. So that is perpendicular to length only. So that now L by 2 distance. This is L by 2 distance. So this total load intensity is W into L. It is acting at a distance of L by 2 from this end also L by 2. That is at center. This is A point, this is B point. Now UDL is converted into point load, my dear students. So now it is a UDL, now it is a point load in terms of point load, my dear students. So this is a conversion of UDL into point load like this. Okay. The next one is uniformly varying load, my dear students. Uniformly varying load. So what is uniformly varying? Uniformly varying. So the load varies, but in previous case the load is distributed uniformly, but in this case the load varies uniformly. Now uniformly varying load. Uniformly varying load. Uniformly varying load or triangular load. Triangular load. So okay, it is represented with UVL. UVL. Now all of you see, my dear students, it is a beam. The load varies uniformly over entire length or part of the length, similar fashion. So similarly UDL, same fashion of the UDL, like this, like this, like this. So see, my dear students, for 1 meter distance, suppose 2 newtons, next other meters, next another 1 meter, 4 newtons, like this. So next another meter, 6, next another meter, 8, like this. The load varying uniformly. So for 1 meter to next 2 meter, 4, like this. The load varies uniformly, either entire length or part of the length of the beam. So here it is represented like this here, W Newton per meter. W Newton per meter. Sir, your distance here is 2 Newton like this. Suppose here is 1, for 1 meter, here is 1, next meter 2, 1, 1, 1, 1, increasing like this. So the load varies uniformly, but variation must be uniform. So that is called as uniformly varying load. See, my dear student, it is in a form of a triangle. It is in a form of a triangle. Now the length of the beam is equals to L. This height is a W Newton per meter. What is the total load intensity? Area of the triangle. Area. So total load intensity is equals to, because it is in a triangular form, so that total load intensity is equals to half into base into height of the triangle. That is equals to WL by 2, my dear student, where it is acting. So for a center of gravity point, here also center of gravity point, but here also the load is acting perpendicular to the length. So that we must consider here. That is, from here to reach L by 3 distance, from here to reach 2/3 of L. So now I am converting this UVL into point load. All of you see, my dear students. So this total load intensity is WL by 2. But it is acting center of gravity for a triangle. Where is the center of gravity? So here is L by 3. H by 3 from here. From here to reach 2/3 of H. From here to reach 2/3 of L. So at this point. Now here is, so from here to reach 1/3 of L. Okay, from here to reach 2/3 of L. Now this UVL converted into point load, my dear students. This is conversion of UVL into point load. All of you clear? It is a very simple, my dear students.